Hello, this is Victor at RestoreMercedes.com. I have this throttle body that I want to repair, so this is the first look at it. I already covered up the sticker because I don't want it to be dissolved. And what do we see? Well, we see an older unit. Obviously this is from a 1994, although it's built in 94, but it was installed in a 1995 model. SL500 R129. This is the carbon deposits. It's what you usually see on the unit that has some miles to it. And actually it was built in 1993. I'm sorry, it's 11th month of 1993. So all of this has to be cleaned up, and of course the wires are totally shot. There is no insulation left on those. They just crumble, and as you can see, that's insulation, all right. So I have to rewire this and obviously do service. I have to service the internals, check up the operation, bench test, potentiometer, clutch coil, all of that. But first things first, this unit has to be cleaned. So that is what I'm going to do next. Okay, this is the first quick wash. Unit looks pretty good, so I think I want to keep this color, so maybe I'll just spray a couple of coats of clear coat over it. Okay, so I continue working on this unit, so it's cleaned up, and I actually ran some clear coat over it. Just let it be, just to preserve the aluminum from oxidation. The internals, I checked out a few things here and there, and potentiometer end over there, and one opening here is stripped, so I have to fix that. And now we're going to look at the wires. So these are the wires that came out of this unit. As you can see, insulation is completely gone. Very bad news. So there's a possibility of a control module failure, the e-gas, but first things first, you want to make sure that your throttle body works perfectly fine before you can actually blame the e-gas being bad, right? So because if the e-gas is good and your throttle body is bad, you're gonna put another bad throttle body and e-gas module will burn. Or if you're going to put another good e-gas module with the bad throttle body, then you're going to burn a next e-gas module. So that's the thing. So right now I'm going to get all these wires replaced, they solder, everything's cleaned up, this and that, and you know, just to move along. So this is where we are. So far so good, and next video probably will be about the final bench test. That's what I'm thinking. Okay, so this is going to be a final part of the throttle body repair, which is right here on the bench test now. Alright, so it's been on the bench test a few times already. I just like never had time to make this final video. I was always busy or whatever, something was going on. But now I finally came up to my senses at 2 a.m. in the morning, so I'll just finish this up because I have to do it. And I need my bench test activator for some other unit. Now, so right now we're going to look at the actual values, and then we'll take a look at overall unit, how it came out, and we'll pretty much be done with this repair progress. Now, first thing is the temperature. Now the temperature on the unit, as you can see, is about 94. That's Fahrenheit. Hottest spot is usually right there where the laser goes, as you can see where the coil is. It hits over 90 Fahrenheit. It's cold in New York, and it can only get to this reading because sometimes you get it over 100, but that's in the summertime because the room temperature is like 66, right? So this one got to 95. And that's just to show that the unit has been energized and warmed up, because this is all aluminum, the heat dissipates pretty well. Therefore, I want to show the temperature just to prove that the unit has been energized for a long time, because it does take hours to get this unit to this temperature. Given that the ambient temperature is like 66, then yeah, it takes a lot of time, lots of time. Now, let's take a look at our values here. So basically what I do need to see here is, given the control module I'm using, I have preset values in this module. Now, you might see these things jump around. That's the software itself. It's not that the micro switches are not making proper contact. It's just the software. It's been doing this for years, and it is what it is. So don't mind that. Now, what's important are the voltages. 0.49, 0.5 as it showed a second ago. Okay, so that is basically the mid-range, so it has to be from 0.4 to 0.6. I hit it at around 0.49, which is right in the middle of the range, which is great. The control module I'm using for this test is set to be at 4.25, 4.26. 1/100th of a volt is just doesn't matter. So that's what's important. The contact switch is permanently on. That's not in the throttle body. So the throttle body has these things and these two. The rest, the motor, the clutch coil, that we cannot see on the computer. Now, let's open it fully. Again, this particular control module allows me to open the throttle body at 90-degree angle. So it's pretty much all the way wide open. And we see that readings follow. It's almost a mirror image, but it will never be a mirror image, because the throttle body cannot go to over 90 degrees. It's usually like about 89. I mean, I'm sorry, this is well, yeah, that's right. The plate, it's late at night, like I said, it's 2 a.m. in the morning, so I have to get going. So 0, 90 degrees, so we're about like maybe 87, 89, because if it goes over, then it might get stuck. So therefore, naturally, just the way it's set up is that it cannot go over like 90 degrees. So therefore, there will never be a mirror image of these voltages, but that's normal. So what's important is the actual change of voltages, and it should be linear, so they should change smoothly. And if there is a problem there somewhere where the actual voltage drops, throttle body will shut down and it will go into limp mode, and we know that it doesn't work properly. Now the actual linkage here, that also has to move pretty smooth, so that does well. Now again, let's take a look at the micro switches that jump on off position, and once I open the throttle body at a certain angle, a certain degree, then they will change over to off on. Takes a little bit of time, but they do change over. That's fine. On the V8 unit, control modules, usually they're not even in play, but with this control module I'm using, I do see all the values, because on the V8s these things will not, I don't know what's going on, they don't change, but this module does. And also on some V8 modules, when you try to open the throttle wide open with the lever, it will only open like about 45 degrees, and that's made so you do not over rev the engine when you start it. In case you just like push the pedal to the floor and you start the engine, you rev it to 6,000 when the oil pressure is not even built up, so that's bad news. So therefore the control module knows it, and it keeps the angle at around 45, so that way it preserves the engine, so you don't like rip the chain or like you spin your bearings. This particular module is different, so therefore it allows me to open it at a 90-degree angle, because that's from a weaker engine, smaller engine, and it allows me to do so because I guess the engineers who created these things, they know better, right? So I'm not gonna question that. Alright, so basically that would be all in terms of the actual test. The temperature is shown, the unit is here, voltages, on off switches, and then the last thing will be is just to look at the unit, what it looks like, and it basically will be ready to go. Oh look, it's been on the bench for a while. It even glued itself down to this mat here, because this mat is to have the throttle body not to shift around on the bench. You see it actually, you know, heated itself up. That's gonna come right off because it was clear coated. So yeah, so this is what it looks like. It's basically, I don't want to put my finger in there, but it's basically ready to go. The plate's cleaned up. I did not polish the plate and surfaces. I never do that. I would rather like clean them nice and with the soft bristles, so I don't have any kind of scratches on the surfaces because they're perfectly polished and machined, and I don't want that to be disturbed. And the rest of the unit, as you can see it, is a good looking, and internals look good. I do not see any signs of overheating, so I'm pretty much satisfied with the way this particular piece came out to be. And this is the part number. This is a SL500 unit. It was produced in 1994, although the case was made in 1993. So, but it seems to be, I believe, the 3rd month of 1994. Here's the first 2 numbers here. That's the year, production year. It says 94, so that means 1994. And yeah, basically that will be all. The unit is ready to go, and that will be all for me. So this is Victor at RestoreYourMercedes.com. Thank you for watching.